For today's lesson, we will be discussing about conic sections, specifically about circles. Before you watch this video, make sure that you already watched the video about the introduction to conic sections. You can find the link down in the description box. So to recall the types of conic sections, we have 4. First is parabola. Next is circle. We also have ellipse. And we have hyperbola. So we will discuss them one by one, and we will start with circle first. So how do we define a circle? Let C be a given point. The set of all points P having the same distance from C is called a circle. So take note of this word, having the same distance. So when we say same distance, that means the points are equidistant from C, which is located at the center of the given circle. To visualize everything, let's take a look at this example. So let's say we have here point P, and then we have here point C, which is what we call as the center of the circle. So, as what we know, a circle is composed of points having the same distance from the center. So, we can identify the distance of P to C. If we get another point, let's say we have here another point, point B, it will also have the same distance going to point C. So, just remember that circle is composed of points having the same distance to the center of the circle. Now we have 2 essential parts for circle. First is we have the center, and then we have the radius. So obviously the center here is point C. We can identify the location of point C. So in this case, the coordinates of the center is 1, 1. So that's the location of point C. For the radius, we can measure the length of the segment formed from point C going to point P. So we can just count. So this is 1, 1, 2, 3. So we can say that the distance of P to C is 3 units. So that serves as our radius. So the center is 1, 1. The radius is 3 units. Again, remember that circle is composed of points having the same distance from the center. So if we will go back to point B, it will also have the same distance to C, which is 3 units. If I identify again another point, let's say here, we name it as point D, it will also have the same distance from point C, which is again 3 units. So all of the points here, okay, on the circumference of the circle have the same distance to center, which is 3 units. So we also have the equation of a circle. So the standard form, which is also called the center radius form of the equation of the circle, is given by the square of x minus h plus the square of y minus k equals r squared, where hk is the center and r is the radius. So hk corresponds to the coordinates of the center, and again r is for the radius. So please take note of this formula. So again, this one is called the center radius form. So in deriving the formula for the equation of a circle, we can use the distance formula, which is d equals the square root of x sub 2 minus x sub 1 squared plus the square of y sub 2 minus y sub 1. So to use this, we should have the center, which is hk. We should also get another point, which is xy. So let's say this is your first point, this is your second point. Again, what I'm showing you here is just the derivation of the formula or the equation of a circle. So we have d equals, then square root of x sub 2, which is x, minus x sub 1, which is h, then squared plus y sub 2, which is y, minus y sub 1, which is k, and then squared. Now, we have here d, which is again represents the distance from HK going to XY. Or this is simply R. So we can replace D with R. And then let's write here x minus h, then squared, plus y minus k squared. Now, to remove the square root, we can get the square of both sides. So, square. So, we have r squared equals, then x minus h squared plus y minus k squared. Now, we can just flip this. We will have x minus h squared plus y minus k squared, which is equal to r squared. So this is now the equation of the circle. So this is how we come up with the given formula. So we use the distance formula to get it. Now let's identify the center and radius of the following circles, and then let's graph them. Okay, so in order for us to identify the center and the radius given the equation, it should be in the center radius form. So again, just to recall, the center radius form is given by x minus h squared plus y minus k squared equal to r squared. So if the equation is already in center radius form, we can easily identify, of course, the center and the radius. Now in this case, since we have here x squared, then we have here y squared, we can write them as x minus 0, then squared, plus y minus 0 squared. Okay, so x minus 0 is just x, then you square it, you will get x squared. Y minus 0 is just y, you square it, you get y squared. And then 9 here represents r squared, so we can write this into 3 squared. Okay, now from here we can now identify the center. So the center of the given circle is, so for h as we have 0, so we have 0, and then for k we also have 0. So that is the center of the circle. And then for the radius, we just have to look here. So r is equal to 3. Okay. So the center is 0, 0, the radius is equal to 3. Now, in order for you to graph this, we can use GeoGebra or Desmos. So let's see how are we going to graph it. So I will show you how to graph the given circle using Desmos. So you just have to go to www.desmos.com and then click graphing calculator, and then you will see this one. So we have a grid. Now all you have to do is you can type in the equation. So we have x squared plus y squared equal to 9. There. So you will see here, this is the circle. This is the graph of the circle. Now, how are we going to know if the center and the radius is correct? So we can plot the point. We can plot the center. Center is 0, 0. So there. And then you can also identify a point. So if you will look here, from the point, let's write 3, 0 there. So from 3, 0 going to the center 0, 0, there will be 3 units. 1, 2, 3. So the radius is equal to 3. So that's how you graph using Desmos. You can also do this using GeoGebra. So you will still get the same graph. Now let's identify the center and the radius of another equation. We have the square of x minus 3 plus the square of y plus 1 equal to 4. So obviously this equation is already in center radius form, so we can easily identify now what is the center and what is the radius. So we can write here center. Okay, so for h, so this one, So we will write here 3. Now, why not negative 3? Take note that the equation or the formula is x minus h squared plus y minus k squared. So originally, the symbol or the operation between x and h is subtraction, or it's negative. So if this is negative here, definitely our h will become positive. Or if it's positive, then you just have to write the opposite sign. Okay? So like in this one, y plus 1 squared. We know originally that the equation is y minus k. So, therefore, k is negative 1. Okay? So, if you will rewrite here, it will become y minus negative 1. Okay? So, again, you just have to take note of the formula or the equation of the circle. So, if it's negative here, just get the number. If it's positive, make it negative. And then for the radius, since we have 4 here, that means we can rewrite this as 2 squared. Therefore, the radius is equal to 2. So the center is 3, negative 1. The radius is 2. Now, let's again graph using the decimal. Okay, so let's graph here. Let's type x minus 3 squared plus y plus 1 squared equals 4. So there you go. This is the graph of our circle. You can also put the center. So we have 3, negative 1 as the center. There. So this is the center. Then for the radius, you can just identify any point. So let's say this one. 5, negative 1. And then if you will count, there are 2 units from this point going to the center. So our radius is correct. So again, this is the graph of the given equation. For our last example, again, let's identify the center and the radius. So we can write this equation as x minus negative 1, then squared, plus y minus 4 squared. Then our 25 here will become 5 squared. So again, we're just using the standard form or the standard equation of a circle. So obviously, we now have negative 1 as the h, and then for k, we have 4. And then for the radius, we have 5. So from the equation, we can see that the center is negative 1, 4, radius is 5. So if, again, the operation here is addition, so you just get the number and then change the sign. But if it's subtraction, no need to change the sign, as is. You have to write the number as is. Okay, so that is the center and the radius. Now, let's try to graph this using decimals. So let's type here x plus 1 squared plus y minus 4 squared equal to 25. So this is the circle. So this is the graph of the given circle. We can type in the center. We have negative 1, 4. There you go. You can also identify another point just to check the radius. So let's say I want this point here. So that is 4, 4. This is just for illustration purposes. So if I will count how many units away is this point to the center. So there. So we have 1, 2, 3, 4, 5. So the radius is correct, which is equal to 5. So this is the graph of the given circle. So that's it for today. I hope you learned something about the first conic section, which is the circles, and see you next time.